Hi guys, back for day 2. So thanks again for being so awesome yesterday. Greatly appreciate that. You guys worked hard, obviously, because I already had some people turning their homework, which is awesome. Just want to remind you of a couple things. So first thing I want to remind you of is don't forget that today you need to make sure you turn in 14.1. Also make sure that you turn in 14.3 if you didn't do that yesterday. And make sure that you turn in your agenda with the questions answered. You should have gotten one of those yesterday from the sub. I think everybody did because I didn't have many left over. If you don't have one, please ask the sub. They do have some extra copies. You have to turn this in. It's for a grade. It's really easy. You turn it in, you get 100. You don't turn it in, then you get a 0. That's how that works. And tomorrow you're going to have 2 things due. One of them is 14.2. That's the assignment you're going to get today. It's going to be a lot like yesterday's assignment. And then you need to make sure that tomorrow you turn in your week 3 bell ringer as well. So I'm looking forward to seeing you guys on Friday. So have fun with the lesson. Bye. So obviously, I'm sure you know by now that today we're spending some time talking about geometric sequences. So remember, when we talk about geometric sequences, we're talking about things that are multiplied to get the next number in the pattern. And that number that we multiply every time, do you guys remember what that was called? It was the common, good, it was the common ratio. So we're going to be focusing today on our common ratio, which is how we find the next number in a pattern where we are multiplying every time. So let's look at this pattern here. So we have 1, 5, 25, 125. Don't say anything out loud, but I'm trying to figure out what's happening every time. Now, some of you are really good at this. You can look and say, hey, I know exactly what's happening. I know that I'm multiplying by fill in the blank, whatever it is. Don't say it out loud. But some of you are like, yeah, no, I'm still not sure how to do that. So I want to give you a way that will help you find the common ratio, because that's probably the hardest one to find. So the way you can do that is you do some division. So I want you to write something down. We can do A2 divided by A1. Remember, A2 means our second term. A1 means our first term. So if I wanted to find the common ratio, I can divide my second term by my first term, which means I can do 5 divided by 1. And 5 divided by 1 is what? Good, it's 5. So that means to get from 1 to 5, I have to multiply by 5. If you were not sure and you're like, maybe that might work, I don't really know, you can repeat the process. You can do the third term, so we can do A3 divided by A2. And this will work every time, which means in this problem I can do 25 divided by 5 and see what that gives me. So I'm going to move over here to the right. 25 divided by 5 is still 5. So again, to get from 5 to 25, that means I multiply by 5. I can do that one more time if you're still not sure, and I can do A4 divided by A3, which means in this problem I would do 125 divided by 25. So I'm going to move that over here to the side. 125 divided by 25. Use your calculators. What is 125 divided by 25? Very good, it's 5. So again, to get from one number to the next, I'm multiplying by 5. That tells me for this problem, my common ratio is 5, because every time I multiplied by 5 to get the next number in the pattern. But I can use this right here, A2 divided by A1, or A3 divided by A2, or A4 divided by A3, to find that common ratio. And again, it works every time. So for these first 3 questions, we have to decide whether it's a geometric sequence. So that means, are we multiplying by something every time? And if it is a geometric sequence, find the common ratio. If it's not, explain why. And we're not going to focus on, well, we will focus on the explaining why part. Sorry, I lied. Not on purpose, but I kind of lied. So problem 1, my pattern says I'm going from 1 to -4 to 16 to -64. So what we just learned was that if we want to find the common ratio, if it's geometric, then to find the common ratio, all I have to do is divide -4 by 1. I'm dividing the second term by the first term, and that's what we wrote up here. And I wrote that in yellow up here too, that I would need to divide the second term by the first term. So what is -4 divided by 1? Good, it's -4. Okay, so what I'm going to do now is I'm going to do that again, but this time I'm going to do the third term divided by the second, because what I want to see is does it give me the same thing every time. So what is 16 divided by -4? use your calculators. What is 16 divided by -4? Good. That is -4. Okay, I'm going to repeat it a third time. And this time I'm going to do the fourth term. I'm going to divide it by the third term. So I'm just repeating that process. So what is -64 divided by 16? That's the next thing I need to figure out. -64 divided by 16. So use your calculators. What does that give you? Good, it gave you -4. So every time we did this division thing, what number did it give us without fail? Yep, it gave us -4. So you know what that tells me? That tells me that this is a geometric sequence, and it tells me that my common ratio is -4. Okay, I'm going to move on to problem 2. So problem 2, my numbers are 3, 7, 11, 15. Well, I've got to decide if it's geometric. So what we just talked about was that I can do some division. I can do 7 divided by 3 and see what it gives me. 7 divided by 3, use your calculators. That gives you what? Somebody gave me an ugly decimal. I don't know who it was, but I know that you did. But that's okay. We're going to take it. 2.3, because I want you to write it down and see what it actually is. So 7 divided by 3 is 2.3. So I'm going to do the same thing, except this time I'm going to do 11 divided by 7. So what is 11 divided by 7? And again, it's going to give you an ugly decimal, and that's okay. So put that in your calculator. Okay, it's 1.57 blah, 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 blah. Okay, here's the question. Are these two numbers the same? When I divided both times, did I get the same thing? No, I didn't. So that means no, it's not geometric because I got different ratios. That's the reasoning why. Is I got different ratios. Again, that's the reason why that is. But you probably, how many of you, and you can raise your hands if you want to, how many of you knew from the beginning that this was an arithmetic sequence? Yeah, why is it arithmetic? Because what's happening every time? Good, you're adding 4 every time. So because you're adding 4 every time, that makes this an arithmetic sequence. So that's another reason why. You don't necessarily have to write that down, but that is another reason why this is not geometric, because it is arithmetic. All right, number 3. So for problem number 3, we're going to do the same thing. We need to decide if it's geometric, so I'm going to do some division. So I'm doing 10 divided by 5, -10, I'm sorry, -10 divided by 5. What is -10 divided by a +5? Okay, make sure you put -2. It's not +2, it is negative, because whenever I divide a negative by a positive, I get a negative. I'm going to do that again, except I'm going to do 20 divided by 10 this time, -10. So what is 20 divided by -10? Good, it's -2. Okay, I'm going to try it again, see what happens. I'm going to do -40 divided by 20. So what is -40 divided by 20? Good, it's -2. So notice every time, did we get the same number? Yes, we did. So that means that -2 is our common ratio. That means -2 is our common ratio. Okay, let's look at problem 4. Write the next 3 terms of a geometric sequence where A1 equals 2. Remember, if they're giving us A1, they're telling us where to start. And R is 1/2. That means every time I am multiplying by 1/2 to get the next number in my pattern. So I'm going to go over here and I'm going to write A1, because we don't have space for that. Well, they don't have a blank for it at least. So A1 equals 2. And they've told us what math to do. To find the second term in the pattern, to get to the next number in the pattern, what am I supposed to do here with this 1/2? Yeah, I got to multiply. So what is 2 times 1/2? Use your calculator if you need to. Or what's half of 2? Yeah, it's 1. So then I'm going to do that again, because remember, this is a geometric sequence. That means I keep doing the same thing over and over again. So I'm going to multiply again by 1/2. So what's 1 times 1/2? Good. Okay, I'm going to do it again. And multiply by 1/2 again. What is 1/2 times 1/2? Use your calculators. Use your fancy fraction. That's probably a good idea. What does it give you? 1/2 times 1/2. All right, 1/4. Okay, so that's the next 3 numbers in my pattern. Cool, that one's done. And number 5, write the next 3 terms of a geometric series that begins 5, 15, 45, 135. So first of all, I got to figure out what's happening every time. Okay, well, let's use those in our brain cells because we have those. And let's figure out what happens. Remember, you can do the math to figure it out. You can do 15 divided by 5 and see what that gives you. What is 15 divided by 5? Yeah, it's 3. Is that true that 5 times 3 is 15? Okay, what is 15 times 3? Good, it's 45. Okay, use calculators. What's 45 times 3? Yeah, it's 135. So that means that's all I got to keep doing to find the next number in the pattern. So I'm going to write A4 here, which is 135. And then to find the next number, what math do I do? What was my pattern this time? Times 3. So 135 times 3 is 405. Okay, I'm going to do that again. I'm going to do 405 times 3 because I'm just repeating that over and over again. What's 405 times 3? Okay, 1215. And I got to do it one more time. So again, multiplying by 3. So use your calculators. 1,215 times 3. What is that? Good, 3645. All right, we are done with the front, so I want you to turn over to the back. So yesterday you learned an equation that you could use to find any number in an arithmetic sequence. Today we're going to learn about an equation we can use to find any number in a geometric sequence. So it has 2 things we need to know, just like yesterday. We need to know A1. What in general does A1 stand for? Every time we say A1, we're talking about what? Good, the first term. Okay, and then every time, you know what else you got to know? You got to know R. What do we say R was? Good, it's our common ratio, what we're multiplying by every time. Now, this formula, so this is a little bit different because notice n minus 1 here, that's your entire exponent. That's important to note that n minus 1 is your whole exponent, and it's going to stay like that every time. This is in what we call exponential form, which is the form y equals a times b with an exponent of x. I want you to write this down and know that we're going to be talking about this for the next week. Okay, this is the next thing we're going to get to is what is called exponential form. And so today, all we're focused on today is we are focused on this equation right here. We're going to be writing a whole bunch of stuff to look like this. So in order to write that equation that we just talked about, we got to know a couple things. So we're going to fill out this information here. Let's start with A1. In general, what does A1 stand for? Not what is it in this problem, just what is A1? How do I know where it is? Good, it's always the first number. So whatever that first number is, which in this case is 3, that's going to give me A1. Okay, to find R, I've got to figure out what is it that I'm multiplying by every time to get to the next number in the pattern. Oops, didn't mean to draw that arrow. Just got to figure out what am I multiplying by every time. And we learned on the front that we could do some division to figure that out. We can divide 15 by 3. What is 15 divided by 3? Yeah, it's 5. That's my common ratio. That means every time I am multiplying by 5 to get the next number in the pattern. So now my job is just to put those numbers in my equation. So I'm going to write my equation here so you can see it. You don't have to because you can see it at the top of your page, but you can't see it on mine. So I'm going to write that equation out, and all we have to do is we have to plug in what we know. So we know our formula is going to be AN equals, it says next I'm going to put A1. Well, what's A1 in our problem? Yeah, it's 3 for this problem. We found that up here. Then it's got parentheses. And then it gives us, it says R. Well, do we know what R is? Yeah, R was 5 in this one, so we're going to put 5 there. And then my exponent is n minus 1. Hey, look, there's my equation. And the beauty of that equation is that equation can be used to find any number that I want to find. But what number is this problem asking me to find? What number does it specify that it wants? Good, it wants the 9th term. That's what it tells us down here is it wants the 9th term in the pattern. So that means that to find the 9th term, I need to plug in 9. So I have 3 times 5 to the n minus 1, but instead of n, I'm not going to put n anymore. I'm going to put a number there. What number am I going to put in? Because what number of term do I want? Yeah, I'm going to plug 9 in there. So type that in your calculators. Okay, remember when you're typing it in that 9 minus 1 is your entire exponent. So you got to make sure you put all that in there. Okay, you type it all in. It's going to give you a pretty big number, I think. Okay, what number does it give you? All right, 1171875. So that is the second half of my answer to this problem. So what I want you to remember is you can use this formula. If I wanted to know the 100th number in the problem, you could use this formula and you wouldn't have to repeat the pattern 100 times. You could just plug it in. So look at problem 7. Okay, so problem 7, I need to start off with A1. A1 is which number in the pattern? Right, the first. And what is the first number in this pattern? Yup, 243. Okay, so now I need to find R. I've got to figure out what my ratio is. So I need to figure out what I'm multiplying by every time to get the next number in the pattern. Well, this one's a little bit tricky. So I'm going to have to do my division. I've got to figure out what is 162 divided by 243. That's going to tell me what R is. Okay, so use calculators. 162 divided by 243. Nope, don't give me ugly decimals. Don't give me ugly decimals. What should you do? Math inner inner. We need it in a fraction. So what does that give us as a fraction? Yeah, it gives us 2/3. So that means my R in this problem is 2/3. That's my common ratio. So now that I have A1 and I have R, I can write my equation. So again, I'm going to write my equation underneath here. You don't have to. I'm just doing it because you can't see my equation because it's at the top. So AN equals A1 times R with an exponent of n minus 1. Okay, so we just got to fill in stuff. So starting with A1, what's A1 in our problem? Good, it's 243. Let me write first. AN equals. So to find any number in the problem, I'm going to do 243 times whatever R is. Well, what was R in our problem? Yeah, 2/3. And then my exponent is going to be, good, n minus 1. So there's my equation, which that equation is going to be useful because now what number in the pattern does it want me to find? What's it asking for here? Good, it wants the 6th number. So that means I need to plug in 6. So 243 times 2/3 to the 6 minus 1 power. So all I did is I took whatever this number was here that it wanted and I plugged it in where n was originally. Okay, so put all that in your calculator. Remember to do the exponent, you use the caret button. Okay, to do an exponent, you use what we call the caret button. It's a little rooftop looking button. What does it give you when you type it all in? Yeah, it gives you 32. All right, so we're done with this. Get out your homework. So you should be looking at 14.2. That's what you should be looking at. I can hear the rustling of papers now. You guys are just, trying to find the assignment. Okay, let's talk about our instructions. So 1 through 6. 1, 2, 3, 4, 5, 6, this top part. You need to decide if these sequences are arithmetic or if they are geometric. You've got to figure that out. So are you adding something every time or are you multiplying by something every time? You've got to figure that out. So look at problem 1. My numbers are 10, 30, 90, 270. So I've got to figure out what's happening every time. So to get from 10 to 30, what could I do? Okay. I've got two options. I could either add 20. So let's see if I try that. 10 plus 20 is 30. Is 30 plus 20 going to give me 90? Nope, so that's not going to work. What was the other option? I could also Yeah, multiply by 3. So 10 times 3 is 30. What's 30 times 3? Good, it's 90. What is 90 times 3? Yup, it's 270. So does that make this arithmetic or geometric? Good, it would be geometric. So I'm going to mark out this arithmetic box, and I'm going to circle geometric, and then R in this problem would be 3 because that's what I'm multiplying by every time. Okay, look at problem 2. So my pattern is 11, 14, 17, 20. So what's happening every time? What am I doing? Good, I'm adding 3. So to get from one term to the next, all I'm doing is adding 3 every time. So does that make this, if I'm adding 3, does that make this arithmetic or geometric? Yep, that makes it arithmetic. So my common difference is 3, so I'm going to circle that one, and I'm going to mark out geometric. Okay, look down at problem 7. So problem 7 through some of the ones on the back, or at least these 4 I know, you're going to need that formula we learned today, that AN equals A1 times R to the n minus 1 power. So go ahead and write that down on your paper. Write that formula down on your notes, on your homework right there. Okay, in order to know that formula, remember I have to know, find out what that formula is, I have to know 2 things. I have to know A1. A1 always stands for what in every problem? Good, the first term. What is the first term of this problem? Yeah, it's -2. So I'm going to start writing that formula. So it says AN equals, instead of A1, I'm going to put -2 times something to the n minus 1 power. So we got to figure out what this something is. We've got to figure out what R is. So to find our common ratio, we've got to figure out what are we multiplying by every time. How do we get from -2 to 6, and 6 to -18, and -18 to 54? Well, today we learned that we could use some math to help us figure that out. That we don't necessarily have to like guess and hopefully we're right. We can actually use math to decide. And to use math, I have to divide. I have to kind of work backwards. I'm going to do 6 divided by -2. What is 6 divided by -2? Okay, good. It's -3. That means that so far I think my common ratio is -3. I'm going to do one more problem because I want to make sure that we're right here. And I'm going to do -18 divided by 6. Okay, use your calculator if you need to. What is -18 divided by 6? Good, it's -3. So that means every time I'm multiplying by -3, that also means R in this problem is -3. So I'm going to plug that in here. So I've got my formula. So let's go back and read our instructions. So find the common ratio. Check, did that. That's R. Find the next 3 terms. That's the next thing I've got to do. And write an equation for finding the nth term of the sequence. Hey, I did that part. So the only thing that I haven't done, okay, so finding common ratio, that's what we did here. Finding our equation is this part down here. So now I've got to find the next 3 terms in the sequence. So that means I just have to keep multiplying by 54. So I got to figure out what would be the next number. So what is, sorry, multiplying by -3. My bad. Okay, so 54 times -3. What is that? Use calculators. What's the next number in our pattern? Okay, good. It's -162. I'm going to do it again because how many numbers in our pattern did we need? Yeah, we needed 3. So now I need to multiply -162 times -3. What does that give us? Okay. I'm going to do it again. Positive 486 times -3. What does that give us? Yeah, -1458. So I've completed all of my steps for this problem because the third thing it wanted me to do was to find to find 3 more terms. Or the third thing we hadn't done yet was to find 3 more terms. Okay, very last thing, flip over to the back. Between 11 and 12, I only want you to do one of those problems. I know I said originally you need to do all of them. I'm changing my mind. For 11 and 12, I only want you to pick one. And yes, these are word problems, but I'm telling you they're still geometric sequences. 13, 14, and 15, I want you to pick two of those. Okay, so 11 and 12, pick one. 13, 14, 15, pick two. Don't forget you have two things that you have to turn in today. Make sure you turn in 14.1 and make sure you turn in your agenda. And I will see you guys tomorrow.